This is a brief introduction to Hopkins' Bioclimatic Law by Nathan West. In this video, we will briefly go over what Andrew Hopkins' Bioclimatic Law is, how it was invented, and what it means for the area of East Tennessee. Have you ever wondered why a single mountain can have more than one biome, how the top of a mountain in the southeast oddly looks a lot like the forest of Canada, or why spring can often be seen creeping up the side of a mountain weeks after it has sprung in the valley? This phenomenon was explained at the beginning of the 20th century by Andrew Hopkins in his Bioclimatic Law. The variation between two or more geographical positions bears the same proportions to the distance between them that 400 days of time bears to 1 degree of latitude, 400 feet of altitude, or 5 degrees of longitude. To put it more simply, Andrew Hopkins' law can be understood to mean that for every 1,000 feet of elevation gained, the climatic changes will be roughly equivalent to traveling 100 miles north in latitude. This will yield an approximate change of temperature equaling negative 3.5 degrees Fahrenheit. This accounts for the variations in the onset of spring, delays ranging from days to weeks, and temperature fluctuations at differing altitudes, while maintaining a constant latitude. What I would like to do now is look at a specific example of how the bioclimatic law works. What we'll do is we'll compare where I'm at right now, which is Johnson City, Tennessee, located at approximately 36 degrees 30 minutes north latitude at an elevation of about 1,500 feet. We're located in the temperate deciduous zone. Right now it is springtime, approximately mid-50s, 60 degrees during the daytime. I'd like to compare the climate here in Johnson City to the climate on top of Roan Mountain, which is a mountain located 20 miles south of where we're at right now in Johnson City. The elevation of the summit of that mountain is 6,285 feet and is known as Roan High Knob. So what I'd like to figure out is what climate and biome we could expect to find on top of Roan Mountain using the bioclimatic law. So first, to do that, we have to determine the difference in elevation between Johnson City and the Roan High Knob. We can do that by simply subtracting 1,585 feet from 6,285 feet, which will give us a change in elevation of 4,700 feet. If we take that change and multiply it by our conversion factors that we've learned, then it'll give us or tell us that the climate found at the top of Roan High Knob will be approximately the same as the climate found 470 miles north latitude of Johnson City, Tennessee. So let's go ahead and plot that on a map. We'll say that we will start at Roan High Knob, which is close enough to Johnson City not to make a difference, and we will pull a line up north from there approximately 470 miles and see what climate we can expect to find at the top of Roan High Knob. As you can see from the map, that places us in the Toronto area of southern Ontario. Let's see where that places us on the climate map. Now that we have this climate map sitting in front of us, we can see that the climate that we would expect to find at the top of Roan High Knob would be similar to that would support a coniferous forest in the southern area of Ontario. This is also the taiga forest, and called the boreal forest, which is characterized by an abundance of low scrub trees and evergreen flora. Obviously, our next step is to drive to the top of Roan Mountain and see if our theory proves correct. As we start at the foothills of the mountain, you can see the deciduous trees flanking the road on the right and the left. You'll see that since it is still springtime, they have not got their leaves back for the year. You'll see some snow starting to accumulate on the sides of the road as we approach the summit. Now, as we are walking around the summit, you'll notice that the The trees and the forest has dramatically shifted from the bottom of the mountain, where we once had deciduous trees with no leaves. Now we are in a forest of evergreen, and this seems to be concurrent with what we would find if we were to travel to 470 miles north latitude of Johnson City to the lower reaches of Ontario. That being what it is, we have little left to say, except for a nice theory, Mr. Hopkins.